Welcome to The Explainer. So, today we're going to be looking at something you probably pass by every single day without even a second thought: a simple green leaf. But we are absolutely not looking at it as just some ordinary plant part. We're actually going to look at it through the lens of our source material as a highly advanced quantum machine. I mean, believe it or not, starting from just a single leaf, we can uncover a system that literally sustains all life on Earth. And what's truly mind-blowing here is that we'll be decoding a 1,400-year-old mystery, one that connects ancient historical text directly to cutting-edge quantum physics. It's an absolutely fascinating journey, so let's just jump right in.
Okay, let's dive into our roadmap really quickly. We'll start with a 1,400-year-old blueprint, move to the quantum mechanics of leaves, explore the engine of biological growth, examine maintaining atmospheric balance, and then finish up with the future of clean energy.
Section 1. A 1,400-year-old blueprint. Ancient texts to modern.
You know, our evolving understanding of plant life highlights something pretty amazing. Our source material points out that long before microscopes were ever even a thought, early Islamic scholars in the medieval era, like Imam al-Razi, were already writing extensively about nature's profound balance. They were actually interpreting 7th century Quranic texts that explicitly mentioned a specific green substance, centuries before 19th century scientists officially named it chlorophyll, and well before our modern-day discoveries in quantum biology. The source specifically points to this text from Surah Al-An'am, verse 99. From it we bring forth green matter, which in Arabic is khadiron, from which we bring forth thick clustered grain. Now, the absolute crucial takeaway here is that khadiron is not just being used to describe a pretty color. The source material explains that it's actually acting as a specific biological operator. It's identified as the foundational machine, literally the absolute starting point for the entire food chain on Earth. And this brilliantly illustrates the massive leap in human understanding. Back in the day, classical traditional interpretations were limited. Scholars could only really observe the macroscopic outputs like visible plant growth and that overarching divine natural balance. But today, modern cellular science allows us to see the actual machinery at work. We're talking microscopic chloroplasts, tiny little rotary motors called ATP synthase, and the literal molecular weaving of carbon. We are looking at the exact same green substance just through a much, much more powerful lens.
Section 2. The quantum mechanics of leaves. Handling solar power.
Now, I want you to really think about this for a second. How does a fragile little leaf survive nuclear-level solar energy without just immediately burning up? A photon is created in a massive thermonuclear explosion in the heart of the sun. It travels 150 million kilometers through the freezing dead vacuum of space and then violently strikes a delicate leaf. Why doesn't the leaf just instantly catch on fire?
Well, the answer to that is quantum superposition. Our sources detail how plants essentially act like tiny quantum computers. When that intense solar energy enters the leaf, it doesn't just bump around randomly like a pinball. It behaves as a quantum wave. It literally travels multiple paths simultaneously through the leaf's complex protein labyrinth to find the absolute fastest, most perfect route to the reaction center. And because of this, it achieves an energy transfer efficiency that is near 100%.
Just to put that into perspective, under classical physics, energy would stumble through a single path, constantly bumping into things, losing massive amounts of power, and worst of all, generating destructive heat. That heat would fry the plant to a crisp. But thanks to quantum coherence, the energy moves as perfectly synchronized wave-like ripples. The proteins surrounding the chlorophyll act as these microscopic vibration shields. And this wave-like energy movement is exactly what prevents heat damage during the light conversion process. It's just an astoundingly elegant solution.
Section 3. The engine of biological growth. Building from air. So let's do a quick educational review of this biological engine in 3 steps. Step 1 is photolysis. The plant uses that incoming light energy as a microscopic sledgehammer to violently split water molecules, releasing oxygen as a byproduct, which, thankfully, we get to breathe.
Step 2 is the Calvin cycle. This is where a specialized enzyme called rubisco acts like a tiny microscopic loom. It literally grabs invisible carbon dioxide gas right out of thin air and weaves it into solid organic molecules. And finally, step 3, compacting. The leaf stacks these newly formed sugars into solid structures to create food and physical mass.
And here's the crazy part. When it stacks them, it uses this exact angle, 137.5 degrees. This is the golden angle, derived straight from the Fibonacci sequence. The source material notes how this mathematical precision perfectly explains the ancient text's reference to thick clustered grain, or Haban Mutarakibeth. By stacking grains at exactly 137.5 degrees, plants achieve the most mathematically efficient biopackaging in nature. They cram the maximum amount of nutrition into the smallest possible space without leaving any wasted gaps.
Section 4, maintaining the atmospheric balance. Planetary regulation. Okay, the absolute crucial number you need to remember here is 21%. That is the exact percentage of oxygen in our atmosphere right now, and it is maintained perfectly, continuously by global foliage. Comparing our deep past to the present really puts this into perspective for us. Billions of years ago, the Earth's atmosphere was incredibly toxic, just choked with massive amounts of carbon dioxide. But then, as our sources explain, the introduction of this green substance changed absolutely everything. Today, we have a wonderfully breathable atmosphere with exactly 21% oxygen. Natural photosynthesis is acting as a massive blueprint for global carbon cycle management. Trillions of leaves are functioning like a giant cybernetic regulatory system, continuously inhaling what we exhale and exhaling what we desperately need to survive. And they don't just manage the air. Leaves also manage another crucial planetary function, thermal regulation. They manage the temperature. They use evaporative cooling through millions of tiny pores called stomata, basically sweating out water vapor to absorb heat. If they didn't do this, that all-important rubisco enzyme would overheat and fail, killing the plant entirely. On a planetary scale, green foliage is basically acting as an automatic global cooling system, maintaining a safe atmospheric balance for all of humanity.
Section 5, the future of clean energy. Mimicking nature.
Because of all this, modern researchers at top institutions, places like MIT and Caltech, are pouring massive resources into mimicking natural photosynthesis. Their ultimate goal? To develop clean, sustainable, zero-emission synthetic fuels. They're desperately trying to create artificial leaves that can take sunlight and water and directly output hydrogen fuel. I mean, just think about the implications of that for a second. Limitless clean energy using the exact same playbook the leaf has been using for eons.
But you have to look at the stark contrast between our modern attempts and nature's reality. Artificial photosynthesis today requires expensive, super rare metals like platinum. The machines we build are clunky, they're loud, they get easily damaged by solar radiation, and honestly, they're highly inefficient. Compare that to natural photosynthesis. A leaf is entirely self-healing. It operates perfectly at a cool room temperature. It utilizes literal quantum mechanics for near-perfect efficiency, and it does the whole shebang completely silently. It is a deeply humbling comparison. Which leaves us with this final, really important thought. As the source material suggests, texts from 1400 years ago pointed to this green substance as the foundation of life. Today, our absolute most advanced science is only just beginning to reverse engineer its incredible quantum and cybernetic mechanics. So, if we are entirely dependent on this brilliant, ancient biological technology for our food, our energy, and our very breath, are we truly acting as responsible managers of this incredibly fragile green system? It's definitely something that should leave us all with a profound sense of awe, and I hope it makes you rethink your relationship with that simple little leaf outside your window. Thanks so much for joining me on this explainer, and keep staying curious.